Hi, I'm Steve Sugden, Chief Technical Officer for the LINQ brand of height safety equipment. When we developed the LINQ range of fall arrest systems, our minimum design standard was for the 5-tick SAI Global compliant product, and we also concentrated on suspension trauma mitigation. However, our research led us to two major concerns, all related to moment of impact. Firstly, the rear or dorsal D setup. So many harnesses have a floating rear D setup, a mere piece of plastic holding the D in place, so that at moment of impact there is a significant risk that the D will break through the plastic holder, resulting in the D and associated hardware smashing the back of the worker's head. This is a major reason fallen workers are rendered unconscious. As you can see, we have now completed a drop test on a competitor harness. Now look where the D has moved. If you look here, you can see where the original manufacturer had marked in chalk where the D was supposed to be positioned for its workers. They had positioned it there. Now after the fall, you can see how much it has migrated. In this instance, it looks like it is 90 millimeters. 90 millimeters is a significant migration, and particularly when you add to it that there would probably be a snap hook or a carabiner on the back, and if you can imagine where the person's back of the head would be. And we have here a statistic. We designed the LINQ setup to be a closed loop system. At the moment of impact, our D is held in place no matter what. No smashed back of the head with the LINQ harness. The second issue, and just as concerning, despite the fact that the Australian standards stating that a fall arrest harness shall have a centered front fall arrest attachment point, the vast majority of harnesses in Australia and New Zealand have a frontal D that is positioned to the left of center. This significantly increases the risk for facial or other injury. The D and the buckle will come up and smash me in the face and at the same time hit me in the sternum, and rendering me to be a mere statistic. And this is the dummy as it is after a frontal attachment fall. Because the D is not centered, you can see that the dummy is now resting at an angle. So at that moment of impact, it's going to cause a vectoral force, which will create all types of problems, particularly underneath the rib cage. And if this piece of webbing grabs underneath the rib cage, you could bruise a rib, crack a rib, break a rib, puncture a lung, and we've got a serious problem. So with LINQ, we've chosen to design our product with a pair of belay loops. So when the belay loop is placed, they're extra size. They're also linked to my buttock, so that in moment of impact, which I'll show in slow motion, I won't get hit in the face. And this is the big reason why LINQ is a better design in this application. Other critical moment of impact factors include padding behind the buckles on the LINQ harness, which eliminates bruising to the worker during the fall. Buckles are placed high in the thigh area and will not result in eye-watering moments. At LINQ, we make our own buckles and webbing, so the design relationship between the two has been carefully considered to ensure correctly and easy fitting harness. Both padding and retroreflectivity webbing is currently unique to the Australian market. Now we've survived the fall, thank goodness. What's next? The tourniquet effect of my harness is causing blood to pool in my legs as venous return is inhibited. My heart is beating faster, my diastolic and systolic rates are plummeting as blood volume around my vital organs reduces. Other symptoms include sweating, tingling in my arms, dizziness, pins and needles, nausea, heart palpitations and confusion, followed by fainting. So how do we prevent this? The LINQ suspension trauma strap totally eliminates the tourniquet effect. All pressure on my femoral artery is removed. It's easy to deploy and easy to adjust. It has also been clinically proven to completely alleviate suspension trauma. I have no pressure in my legs whatsoever, and I can happily hang here. I have in fact hung for more than 2 hours in the laboratory during our medical trials. Now, correctly fitting a harness is critical to ensuring it can do the job it was designed for. In the event of a fall, if a harness is incorrectly fitted, the force distribution changes in the moment of impact, leading to increased injuries such as head or facial injuries. Correctly fitting means both ensuring it is the right size for the individual, as well as ensuring it is worn and adjusted correctly. Often, workers think they are wearing the harness correctly when they are not. A good harness should shepherd the worker into the correct fit. If they have it wrong, it should be blatantly obvious. LINQ harnesses achieve exactly that. Limited leg strapping guides the wearer into adjusting the shoulder webbing correctly and ensuring the belay loops are connected underneath the buttocks and in a positioning where the fall arrest hardware presents no danger at all. Lanyards are a critical component of the fall arrest system and can mean the difference between a severe injury at the moment of impact and walking away unharmed. Australian standards state lanyards must limit average stopping forces to 6 kilonewtons over any one period of 50 milliseconds. The LINQ range of lanyards limits the average forces to less than 4.8 kilonewtons over 50 milliseconds, significantly reducing force on the body during that moment of impact. All LINQ fall arrest safety products have been painstakingly designed, painstakingly engineered to provide class-leading protection in the moment of impact and, of course, after it. LINQ's fall arrest systems are competitively priced and are built upon pro-choice safety gear's foundation of providing only the highest quality at a fair price.